Let's use the units to identify what variables are given. Liters is a measure of volume, kilopascals is a measure of pressure, Celsius is a measure of temperature, and the question is asking us to solve for mass in terms of kilograms. So given 3 out of the 4 variables, let's use the ideal gas law, which says pressure times volume is equal to the number of moles of an ideal gas times the universal gas constant times the temperature in the Kelvin scale. But we can solve for the number of moles and convert moles to mass using the molar mass from the periodic table. Before we start, let's change the temperature from the Celsius scale to the Kelvin scale. We can do that by adding 273. Next, let's rearrange the ideal gas law to solve for the desired variable, which is the number of moles. So the number of moles is equal to PV over RT. Now we can plug in the values given. Pressure is given to us as 2.00 times 10 to the 4 kilopascals, which is just 20,000. Volume is given to us as 20.0 liters. And that's going to go over. Now we need to use the universal gas constant that has units that matches our units of pressure, which is kPa. And temperature, we converted earlier as 301 Kelvin. So that's how many moles of nitrogen gas are in this cylinder. Now let's use the molar mass to convert moles to mass. The molar mass of nitrogen is 14.01, and there's 2 of them in diatomic N2. So the molar mass of nitrogen is 28.02 grams per mole. We need to set up a conversion factor to get rid of moles and end it with grams. So that's how many grams of nitrogen are in the cylinder, 4479. Finally, we can convert that to kilograms by using the conversion factor 1,000 grams is equal to 1 kilogram. Our final answer should have 3 significant figures because all the measurements given have 3 sig figs on their absolute scales. So the answer is 4.48 kilograms. You can just move the decimal over 3 times to the left because that's the same thing as dividing by 1,000.